Good morning, and thanks for the introduction. Good to talk about something a little bit different today, revolving around civil nuclear policy, but hopefully it's still of interest to you. So, plant life extension, or PLEX, is the term used to describe the activities undertaken to extend the life of a nuclear power station beyond its original design life. And really what I want to cover today is three main themes. Firstly, why do we need it? Secondly, what are the challenges, and importantly the technical challenges for PLEX? And then lastly, what do we need to do to deliver that, and do we need a strategy to deliver that? So to give you a bit of context, by the end of the next decade, the majority of the UK's existing nuclear fleet will have reached the end of their operating lives and will come out of service, starting with Wilfa Power Station on Anglesey at the end of this year. And while the next generation of nuclear power plants is expected to come online towards the end of this period, as this graph shows here, the UK's generating capacity from nuclear is not expected to return to its current levels until at least 2025. This downturn in generating capacity coincides with the closure of several fossil fuel power plants and really represents a crucial pinch point in the delivery of baseload electricity for the country, threatening our ability to meet demand and also increasing our reliance on energy imports. It's important to note here that this pinch point is based on current projections for new nuclear, something which presents its own challenges. One of Europe's leading new-build projects, the Flamanville 3 PWR reactor being constructed on the northwest coast of France, is really a clear example of the challenges in delivering an infrastructure project of this size. The nuclear plant, as the statistics show here, is currently over 5 years late and over €5 billion over budget. It was recently reported in the media this is placing the company Areva, who are the reactor vendor for this plant, into severe financial difficulties with significant redundancies and takeover bids expected. This is a similar design to what's been proposed to be constructed at Hinkley Point C down in Somerset. Furthermore, discovering of manufacturing anomalies in the reactor pressure vessel, which is a key safety critical component, is likely to cause further delays to this project. So to address the UK's energy challenge, we simply cannot afford our own new build programme to suffer the same fate, but we must accept, given our country's track record at large infrastructure projects, that the current projections for connection of new nuclear to the grid are optimistic. This has been made evident through continued delays to the final investment decision at Hinkley Point C. And therefore, if we cannot rely on the early or even on-time delivery of new nuclear for the UK, we need to look to maximise the benefits that we can gain from our existing nuclear fleet. So, plant life extension, or PLEX. It's not a new practice for the UK civil nuclear industry. EDF have announced several operating extensions to many of the UK's advanced gas-cooled reactors, most notably 10-year extension to Dungeon SB power station in Kent. However, it does become increasingly difficult to achieve as the plant gets older, greater effort, increasing technical complexity, greater cost. The fundamental potential for successful PLEX activity is driven really by the condition of the plant structures and components, those which are critical to either the safety or reliability of the plant. And the PLEX activities undertaken by the operator are largely focused around these areas, looking to reduce conservatism, reduce loads, or even replace items of equipment. However, the influence of component condition on the decision to grant PLEX is at its most influential where replacement of components is not possible. Unlike their PWR counterparts, like the US and France, two of the most important components on the nuclear island, namely the reactor core and its internals and the steam generators, are irreplaceable on the UK's AGR fleet. And really it's here where the greatest technical challenges lie. The advanced gas-cooled reactor design, which is unique to the UK, is graphite moderated, where the core is comprised of a number of graphite bricks. The properties and stresses on these bricks are changing over time, resulting in aging mechanisms of weight loss and brick cracking. Some of these mechanisms have previously been unpredicted, and the prediction of even the known mechanisms is challenging, as it can vary considerably between bricks and within. These issues could eventually drive increased inspection frequency of the reactor core, which will result in more operational downtime to the stations. In addition, there are some specific issues experienced on AGR stations around the boiler structures, including cracking of the boiler spines on Heysham 1 and Hartlepool power stations, as reported quite widely in the media. And that's resulted in significant operational downtime at those stations. This has really started to drive development of really unique inspection techniques and the implementation of additional protective safety systems to these plants, which is something that I'm involved in, delivering some systems to Dungeon SB to support that life extension. So really the crux of the question is, why is this all important? What's the challenge for the UK? Well, currently, the decision to implement a Plex programme is largely driven and at the discretion of the operator, who will also make the financial investment for that decision and associated with that programme. Cost is a really key influence in the potential for Plex, and the Plex decision will largely be driven by the commercial viability of recouping that investment by additional years of electricity generation. Whether that generating time will be lucrative for the operator, there are a number of external factors which present a risk to that Plex decision. Looking at the US, several of their PWR stations have closed early, before even reaching the end of their original design life, and many more are at risk, as the statistics there show. This is largely due to unfavourable economic conditions and a reduction in wholesale energy prices due to the advent of shale gas. Whilst fracking is not expected to have as significant an impact on the UK's energy market, this is likely to be one of a number of risk factors that EDF Energy will consider when deciding to make a Plex programme for one of their plants. So the question that we really need to ask ourselves is this then: do we want to leave the decision on maximising the capacity of our existing nuclear fleet and bridging the pinch point in our national energy supply down to the operator? And should we expect that operator to bear both the financial and the technical burden in achieving this? And it's due to that question that, in my opinion, I think we need a more complete and coherent national strategy for Plex. And I think it needs to cover 4 key areas. Firstly, we need to work more closely with our operator to really understand where those technical challenges lie, and at what stations we have the greatest likelihood of overcoming these challenges. We need to engage more strategically in R&D, particularly in the area of graphite behaviour. Well, there are several research programmes underway in industry and academia looking at this area. The UK government's review of the civil nuclear R&D landscape, which was published in 2013, did not even identify Plex as one of the government's priorities relating to nuclear energy. Given the importance, as I've said, on Plex and delivering nuclear electricity generation over the next decade, this really has to change. We also need to fully understand the capability of, as I've called it, the UK PLC as a whole in delivering Plex, and really drive the utilisation of that capability to share that technical burden with the operator. But lastly, and I think most importantly, we need to provide financial support, either through direct funding or through guarantees. Electricity generation within a free market tends to drive short-term decision making, and we need to convert the decision on the future of our nuclear generating capacity from that of a commercial one made by one company to that of a more strategic one made by and for the country. Thank you.